I just kind of paused the video for a second because I need to double check something. I did notice I made a mistake in that because there was some inconsistency in the last part I did in red. I think I made a mistake up here and I forgot that negative there. Okay, so that was, if you want to change that in your notes, that should be a negative there, which then changes this here, and we end up with a slope of positive 3/4. Okay, so that's what it should look like. And when I did this, although this is the results are not are still the same, it didn't really match the picture. That's why it made me take a look at that. And I looked at that and said, oh, wait a minute, that curve here looks like it's going positive there and it's going to go positive there. So when I double checked that, yeah, sure enough, my slope was wrong. It's not negative 3/4, but positive 3/4. Regardless, it still makes that non-differentiable at that point. Okay? So, moving on to part D then. Part D, the last part of this question asks us to evaluate the area under the curve, or the integral from 0 to 5 of f of x times x, or x times square root of 25 minus x squared. Okay? So then, if I want to do that, when I set up my integral, well, this is not a standard integral, so I need to think of some strategies. Well, I'm going to use substitution here. When I look at my substitution, again, there's an inside part, and as I differentiate the inside part, it seems to accommodate the outside part, because the derivative of x squared is going to be 2x. Okay, so then I'm going to try that, and it should work. So I'm going to let u equal the inside. Okay, du then is the derivative of that inside. Move the dx to that side, and sure enough, my negative du over 2 is equal to x dx, and that's the part that accommodates the outside portion, so I can set up my integral to anti-differentiate this. So then, when I work this out, then I'm going to set this integral up in terms of my u. So I'm going to put in u, okay, and then the x dx can be replaced by negative 1/2 du. So there we go. There's my integral, and I'm going to evaluate this. Oop, I need to change this. I have to be careful when I change the variable. I have to be careful about this because I have to make sure that the bounds then are for x and not for u. Okay, so there we go. X equals 0 to 5. Now it's a little bit more of a formality because we're going to end up changing it back to x. But if we left it at 0 to 5, it would imply that we're integrating from u equals 0 to u equals 5. Okay, and if we want, we could actually solve for u using that expression from x equals 0 to x equals 5. We can just plug in to find out what the u's would be at that point. So I'm just going to do this for x's, because then in general we change it back to x's. So I end up with negative 1/2 from x equals 0 to x equals 5, and it's going to be, and I'm just going to do this to the power 1/2 du, and my u function is 25. Oops. Well, sorry, I have to anti-differentiate this first, don't I? Okay, so I'm going to anti-differentiate this before I substitute back for u. So it becomes negative 1/2 u to the power 3/2, and we're going to evaluate this integral from x equals 0 to x equals 5. Now I'm going to change it back to x's, or the option would be then is also to actually, we can change these x's into u's using that equation. I'm going to do the former. I'm going to change this back to x's, so I get 25 minus x squared to the power 3/2, and that's from 0, x equals 0 to x equals 5. So then I can evaluate this integral by just substituting in. So negative 2, and plugging in here, I get 25 minus 25, which is 0, minus 25 to the power 3 over 2 when I substitute in the 0, and square root of 25 cubed is 125. Well, I'll do this in steps here. I get negative 125, and that works out to be positive 125 over 2. Okay, so there is my, and this is units squared. This is the area above that curve. We could also think of the displacement on the antiderivative is going to be 125 over 2. All right.